So we will now be telling you how we make our insulation and what where our innovation lies. So right now we'll be making two distinctive control experiments. The first one, as you can see here, we are making a polyurethane foam, which is being normally used in the industry. So this foam is made up of methyl acrylate and polyol, and here you can see we are adding the methyl acrylate solution to the polyol solution. So these two monomers we have to be mixed at a consistent ratio, and they have to be stirred properly and left at room temperature for it to polymerize. On mixing properly, we have transferred the solution into a plastic dish, and within a few minutes, as we will see here, this solution will expand into a foam after 5 to 10 minutes. This is how normally polyurethane foam is being made. The whole process takes place at room temperature, and this is a real-time video about how the puff is being expanded, and this is what the end result is. So for easy comparison for our results, we have made the normal puff solutions into a box, and this is what it has been expanded to at room temperature. Now we will making our novel insulation, wherein we'll be using the same puff as a substrate, and we'll be adding a new chemical inside which can increase the thermal properties and decrease the thermal conductivity. Here we are adding the polyol solution, and then we'll add the methyl acrylate. To this, we'll add the chemical which will act as a heat storage system, which stores the heat in the form of its latent heat at 25 degrees centigrade. So this resulting solution has two types of insulation. One is a static insulation, which is given by puff, and another is dynamic insulation, which is given by this chemical which is being added. On mixing, this whole new material or the mixture doesn't polymerize at room temperature, and hence we have to transfer it to an oven and bake it at 90 degrees centigrade. This is very crucial for us because the material of the box that we are using is FRP, or fiber reinforced plastic, which also requires curing at 90 degrees centigrade. So since the insulation and the box material both requires curing, we can produce the whole composite at one go at 90 degrees centigrade by putting inside a oven. After 5 minutes, this is what we get. It expands, as you can see here to the left side. This is our novel insulation, and it has expanded to a much lesser amount as compared to the puff. The puff on the right hand side is highly brittle and it breaks off very easily, as you can see here. But in case of this insulation, what we have produced, it is hard to break and it is highly dense. So it doesn't break off easily. So it has a very high mechanical strength as well as low thermal conductivity. And since it is highly dense, the thickness of the insulation of the box becomes very less. And hence we can increase the storage space of our box as compared to normalized boxes. This is what we have used in our material. Right now we are going for the commercialization of the box, and this is the final product, how it looks like. It is made of FRP, and it is made up of 4 notches, where this is where the thermal batteries will go inside. And inside the thermal batteries, they have a very high conductivity, and it skips the perishables inside at lower temperatures. This is the mold which is being used for making the boxes. This is the outer casing, and this is the inner casing. The hollow portion that you can see here, this is where we'll be pouring in the modified insulation that we were shown before. This is the mold for the lid. And as I told you before, this is where we'll put the insulating material inside and along with the FRP material, and we'll put the whole material inside the oven for curing. And hence the whole composite comes out at one shot. We don't have to go for extra milling processes. So this is how we make the boxes on the commercial scale.